Again, to emphasize the purpose behind try-catch blocks is to separate code that's designed to handle errors or special circumstances or exceptions to the norm from the normal programming tasks that the programmer is responsible for. And by doing so, we make it much easier to read and understand our programs and to modify them. You should be aware, however, that it does require more time and resources. There are penalties to pay for this mechanism called the try-catch block. And the reason for that is it requires instantiating the exception object, which takes time, and rolling back the call stack and propagating errors to the different calling methods. That all consumes resources. So that's the penalty we pay for the elegant solution of a try-catch block. But it does mean we need to be careful how and when we use this mechanism. We talked about rethrowing an exception. You might wonder when it's appropriate to throw an exception back to your caller. And the answer is simply that if you can handle the exception because you have all the information you need and you know what to do and you know how to deal with it, then there's no need to rethrow the exception and you should handle it right then and there in this particular method. If for some reason you are missing information that only your caller will know, then only your caller is in a position to handle it, and in that case you should simply rethrow the exception instead. A more general question is, when do we use exceptions in the first place, or when should we? So we see that we have this try-catch block available for our use, and we know that we can use it to deal with unexpected errors. But the piece of advice here is we shouldn't use it if the tasks we're using it for are simple expected situations. For example, if you take a look at the following code, we have a try-catch block, and this is probably not an appropriate use of try-catch because of the extra resources that are required to support try-catch. We talked about those a slide or two ago. So we could say try system.out.println refvar.toString, and if it turns out that the reference variable doesn't actually point to an object, then that's going to create an exception. It's called a null pointer exception. So then we can turn around and catch null pointer exceptions here and print out an appropriate message that says refvar is null. This will work just fine, but it's overkill and consumes extra resources that aren't necessary to consume. In the next slide, we'll see a more appropriate solution for this. So what you saw in the previous slide is better replaced by what we see here. You simply do an explicit check of refvar to see if it's null. And if it's not null, then you know it's safe to go ahead and use it in conjunction with the toString method and go ahead and include that in a system out.println. Otherwise, in other words, else, then we know that we should just print an error message indicating that refvar is null rather than try to attempt to use it with the toString method. So although the try-catch block solution in the previous slide will work, this is a more appropriate solution because of the simplicity of the particular problem we're dealing with. Sometimes when an exception occurs, it may be necessary or desirable to throw a new exception with additional information along with the original exception. And when this happens, it's referred to as chained exceptions. The idea of a chained exception is shown in this particular slide. In the main method up at the top, we have a try-catch block, and within the try block we call method 1. If you go down to line 11 of the source code, you see the definition of method 1, and it's declared to throw an exception. In turn, it has its own try and catch blocks, and in its try block it calls method 2. If you go down to line 20 of the source code, you'll see the definition for method 2. Method 2 has also been declared to throw an exception. And when it executes, all it does is it actually goes ahead and throws an exception. So in line 21 we see throw new exception, and in the argument for the constructor for the exception object is the string new info from method 2. This exception is now thrown, and that means we're going to abort this method that we're in right now. Well, there was no lines of code left there anyway, but that's beside the point. We abort it, and we then find ourselves back at the caller in line 13. We're now going to scrap the rest of the try block in lines 12 to 14. Once again, that was the end of the code anyway. There was nothing else left to do, but nevertheless, we abort the try block and we move on to the catch block. In line 15, our catch block is designed to catch exceptions of type exception, and that is the kind of exception that was thrown. We call it EX in this case, and what we do in response in this catch block to process this exception is we in turn simply throw a new exception, and we include new information from method 1 that we're currently in. And you can see this is the first time I think we've seen this so far in these slides, but we have the usual string that we put when we're creating an exception object, but we also have another argument. So this is actually a 2-argument version of the exception constructor, and the second argument is just the exception object that we caught, EX. So now both of those pieces of information go back for the ride to our caller, and our caller was of course in the main line. So on line 4 we were called from line 4, and now because an exception has occurred, we now abort the rest of this try block. And again, it's only an illustrative example, so there's actually no code left to do there, but in any case we're still technically aborting the try block and going on to our catch block. The catch block for the main method, which in line 6 here, is designed to also catch exceptions, and that's the kind of exception that we have been thrown, so we do catch it, and now we do a print stack trace on that exception object. The output from doing this, or at least most of the output, is shown in the red box off to the right hand side here. You can see that at the bottom it says one more. That's what this thing prints when it only prints a reasonable amount of output, and then it just tells how many more lines of output there would be if it was going to show all of it. So this is exactly what we're going to see then, is what you see here in this red box. This tells us information about who called what and when the exceptions occurred and so on. So it's a full listing, a detailed list of the call stack of what happened.